Heinemann Higher. Chapter 6, Differentiation, mixed questions at the end, exercise success, number 2. Again, it's just differentiate, only this time they've chosen some different sets of variables. That just means whichever form I want to use. I could use s dash, but I think I'll just go for, if s is expressed in terms of t, then it would be ds by dt. And conveniently, everything's perfect, separate terms, power shown, t's on top, the variable's on top, so it's just multiply by the power, 4 3s are 12, take 1 off the power 3, multiply by the power, 2 5s are 10, take 1 off the power 1, don't need to show it, constant term, doesn't change, no derivative, forget it. That's it done. Next one, s equals, so ds, variable t, ds by dt. Again, it's convenient, a single term, I can see the coefficient, the variable's on top, I can see its power, multiply by the power. 4 times 5 upon 2. 4 times 5 upon 2. So the 2 will divide into the 4, divide by the bottom to give 2. 2 5s are 10. So it's 10t, 1 off the power. Now since it's halves you're dealing with, 1 is the same as 2 halves. So it'll be 5 take away 2, which means you're left with 3 halves. And I'll leave my answer in that form rather than writing the square root of that cubed, because that was the form it started with. Yeah. Now see, the problem this time is it's all jumbled up. I've got these products and I've got divisions and so on. I need separate terms. I want this to look like that. So I've got the separate terms. I can see the coefficient, I can see the power. So the first thing I'll need to do here is multiply out that bracket. It's the square of a bracket, so it'll be square the first. So that'll be t to the 4. That'll be square the last. That'll be plus t squared. And it'll be twice the product. The product would be t times t squared is t cubed. So doubling that, 2t cubed all over t. And then you could go straight in with the answer without having to spell out the bits, because each of these is being divided by a t. So I've got t to the 4 divided by a t, which will be t cubed. I've got 2t cubed divided by the t, which is 2t squared. I've got t squared divided by the t, which just gives me a single t. Now it's fit to go, so I can differentiate it. ds, because that variable's s, by dt, because that variable's t, multiply by the power, 3, take 1 off the 3, 2, multiply by the power, 4, take 1 off the power, 1, don't need to show it. Linear term, coefficients, just 1. That's that one done. Nice and easy. Same with this one. Now these are actually quite easy because there's no roots or denominators involved in these. Again, I'll need to multiply this out first. So square the bracket, square the first, twice the product, negative 4, negative 8t, square the last, plus 16. Finally multiply it out to get my separate terms. T cubed minus 8 times t squared plus 16 times t. Now I can differentiate it. ds by dt is nice, clean and neat. Multiply by the power, take 1 off the power. Multiply the power, 2 8s, negative, negative 16. Take 1 off the power, just 1. Linear term, so it'll just be the coefficient 16. And there it is. Question 2.